All right, so let's shift to kidney function. So creatinine is also included in the phenol wage, and then we can also drill down if you have cystatin C and blood urea nitrogen, uric acid.
Yeah, I don't do if I can even say it, cystatin C that often, so I don't have very many data points for that, but the rest I do. So, which one in particular did you want to see? Did you want
Yeah,
to see?
let's zoom in on creatinine.
Okay, so we're right there.
I don't know if you want to talk it through, or I should go through it.
No, go for it. You do
Yeah.
it. You do it better than I do anyway.
Ah,
So,
so here, yeah, I see your trend 2017 relatively high, and then you've been reducing it over time, which is good news. So
I've had a
most
few
recent,
high points there too. Yeah.
oh wow, super high points. Yeah. Um,
I know that's affected by my creatine consumption.
all right. So have you consumed less creatine over time?
No, not intentionally. No. I try to consume the same amount, but um, again, most of that is in with my morning protein smoothie. And if I'm traveling, which I've been traveling a lot, then I haven't been getting my creatine. So that could be another reason why this has decreased.
So more traveling over the past, well, 8 years, more traveling, less shakes that.
Oh, no, like since I retired. So it was just within the past maybe 3 years.
Yeah, but you can see the trend line goes all the way back. I mean, this is 2020,
Yeah.
just starting from there. Yeah, all right, but that could be a part of it. But anyway, all right, so going in the right direction. So for more insight, blood urea nitrogen. So assuming your protein intake is constant, kidney function declines during aging. And one of the functions of the kidney is to basically remove substances from blood, urea being one of them, blood urea nitrogen being a marker of urea in blood. So if your protein intake is a constant, when considering kidney function declines during aging, if blood urea nitrogen has increased, then that would suggest reduced kidney function. But again, key point is if your protein intake has been a constant.
Well, here's my blood urea nitrogen, and it has been increasing.
Yeah. But
Yeah.
I get you've increased protein intake over the past 8 years.
Yeah, again, I don't think that I have. I think I'm still staying pretty consistent with my protein intake.
Yeah, so this is an interesting one because the creatinine decrease suggests better kidney function, but if that's just a measure of less creatine, we may be masking the real situation. And if your protein intake levels have been stable over time, um, this could be related to a decrease in kidney function, but we'd have to have more specificity in terms of, how much protein were you consuming? How much is it now?
Yeah, we can look at stuff like, EGFR, which declines with age.
So EGFR is derived from creatinine. So this is basically the same measure.
Yeah.
Like the equation uses creatinine in the measure, but uric acid can give us more insight. So if uric acid is also increasing like blood urea nitrogen, that would suggest that we're on the wrong side of kidney function.
So let's see, my uric acid. Oh, there's my cystatin. See,
Two data
cystatin.
points.
Only 2 data points. That's it. Yeah.
Do you have plans to measure that more often or not so much?
I do now. Before didn't really realize it was a worthwhile variable to be looking at.
So besides it's as a marker, it's less sensitive to changes in muscle mass relative to creatinine as a marker of kidney function. But besides that, so GrimAge, the DNA methylation test GrimAge.
Yeah.
So GrimAge is and this isn't hyperbole. GrimAge is the best epigenetic clock for its association with all-cause mortality risk. So I have a paper open in my tabs where it looked at all-cause mortality risk head-to-head matchup, PhenoAge, not the PhenoAge, the blood-based, the DNA methylation um, estimation of PhenoAge, Horvath, Hannum, Dunedin Pace. And the clock that had the largest association with all-cause mortality risk by far was GrimAge. So then it raises the question, what is GrimAge trained on? And one of the proteins that, so you've got, so it's 7 proteins and it's smoking pack years, and I think chronological age. And it's right. So they took actual levels of those 9 variables. If I'm leaving one out, whoever's watching that's going to grill me on that, forgive me, but 7 proteins, right? So they took those actual measures and then did the epigenetic prediction and then used that epigenetic prediction for all-cause mortality risk. So of those 7 proteins, cystatin C is on the list. But then note that just like PhenoAge, where RDW is the strongest predictor or strongest contributor to the PhenoAge number, um, all 7 proteins didn't contribute to the GrimAge in value, right? So some are more stronger contributors than others. For example, leptin is on that list, and leptin was basically weak, but still significant in the GrimAge prediction. Cystatin C's correlation with the overall GrimAge score was very high. It was like zero point 0.9. So I've included that on every test now going forward. For me, I'd rather have the actual biomarkers rather than the prediction GrimAge.
Yeah. Yeah. So which ones do you do every time now? Cystatin C and leptin, both?
Not leptin. So actually leptin, because it was so weak, and leptin's proportional to fat mass. So, we're already lean. I can't imagine it's going to be high. Now, granted, if I started to increase body fat, I'd see higher leptin, but leptin is a low value one for me. Beta 2 microglobulin is also on
Uh,
that list. And that I'm including that for the first time next week. I'm going to do that for every test. That's
I have
also,
one test for each of those. That's why they didn't show up in the graphs.
aha, nice.
So I need at least two data points for those to show.
Gotcha. But those are the two big ones that I'm going to measure. The other ones like GDF-15, not commercially available, but very strong predictor of grim age. And there are a couple other ones like TIMP1 or TIMP something. Never heard of it before. Very
Mhm.
strong predictor. And then PAI1, but it's core that's commercially available, but its correlation was weaker.
Yeah, so cystatin C is not in one of my normal panels, so I would just have to do that as an add-on from here on out.
Yeah, I think it's important. I'm going to keep including it, trying to get it as low as possible.
So my uric acid, you mentioned that. That should show up here somewhere else, but it's not showing up as a kidney health marker.
Hmm.
So maybe it's listed as a liver health marker. I don't know.
Yeah.
Yeah, uric acid. Here
Uh,
we go. All right, so let's zoom in on that one. That one at least looks like it's going in the right direction.
yeah,
Oops.
definitely. So this is good news. The way I interpret this is the decreased creatine, less creatinine. So we can't say anything about your kidney function yet, because it may be influenced by creatine. Your bun is probably impacted by protein intake. And the reason I say that is because your uric acid is decreasing. If kidney function was declining, I'd expect to see an age-related increase for uric acid, not a decrease, with lower moving towards lower all-cause mortality risk. So this is good news. Then the next question is, when considering your bun is increasing, so urea in blood is formed from nitrogen. So your body will remove nitrogen, say from proteins, and then form urea. So urea has 2 nitrogen groups. So then it raises the question, is your protein intake a bit too high? And because urea isn't just the metabolite in blood, so urea in very high levels can circulate to the intestine where it can degrade the tight junctions, allowing for more stuff to leak into the blood. Now, is that at your current level? I don't remember. I think it was like 18 or 19 milligrams per deciliter. Is that high enough to do that? Um, I don't know,
Don't know.
but that could be something to experiment with as a suggestion. Maybe cutting protein intake 10 or 20 grams and seeing if that reduces blood urea nitrogen, but then also maybe you get a boost in other biomarkers too. Because if it's too high for blood urea nitrogen and that is allowing for stuff to leak into the blood, you may see changes, whether it's HSCRP or alkaline phosphatase.
We can look at those too. So here's the total protein that you were interested in.
So total protein is more a marker of albumin plus globulins. So not
Okay.
necessarily a marker of protein intake. And so, in very old people, usually albumin is thought of as a marker of malnutrition, but anecdotally, I don't know. In my data, protein intake doesn't correlate with albumin, globulins, or total protein. It's more tightly regulated than that.